Hi, still looking at ions, all right? There are two types of ions. Some ions are called cations, others are called anions or anions, all right? So last time in the other video, we defined an ion as simply a charged particle, all right? So we noted that if it's positively charged, we call it cation. If it's negatively charged, we call it anion. So today we're looking at this anions or anions. All right. Okay. So let's proceed. Just like cations, anions are also categorized into three. We have monovalent, we have divalent, and we have trivalent anions. All right. So mono means one, di means two, and tri means three. These numbers are basically valences. When you say valence, we mean the combining power of that atom or an element. When you say combining power, we mean the number of electrons it has to gain for it to be stable, since they are nonmetals that we are focusing on today. So the number of electrons that it will have to gain for it to be stable. All right. So let's delve in examples for monovalent. Now, when you say monovalent, you mean elements that will only need to gain an electron for them to be stable. So those are elements like elements in group 7 of the periodic table, halogens. All right, those sort formers. So let's pick just one simple one, which is fluorine, and its mass number is 19 and its atomic number is 9. All right. So if we say what's the number of electrons, what's the number of protons, what's the number of neutrons in a neutral atom of fluorine, what we are going to get is 9, and what is 19 minus 9? That is 10. So neutrons are 10, protons are 9, electrons are 9. Remember, it is a neutral atom of fluorine, hence these two are equal. All right. So to explain further what we're trying to look at, we are saying if we are to draw the electron structure, we know that in the first shell we are going to have 2. In the next shell we are going to have 1, 2, 3, 4, 5, 5, 6, 7, right? But for it to be stable, we need how many electrons? 8. It's an octet stability that we are talking about here. So 1 electron is going to come, for instance, from sodium. The sodium that had lost an electron in that other video is going to come and make 8 here. So 2, 4, 6, 8. It's now stable. Okay. How many electrons does it need to gain? Only 1 electron. Hence monovalent anion. All right. Good. Let's go quickly to divalent. Divalent, we can pick an element that has the valence of 2, and the one closer in my mind right now is oxygen. Okay, oxygen has the atomic number of 16, and mass number of 16 and atomic number of 8. Okay, so if we say electrons, protons, and neutrons, how many are they? We know that since this is a neutral atom that we're talking about, it means electrons are 8, protons are 8. Since they are equal, it's electrically neutral, right? It's electrically neutral. It's not positive, it's not negative, right? So an atom, before it loses or gains electrons according to its valency, that atom is neutral. An atom, before it does that, it's neutral. It's electrically neutral. It becomes electrically charged, positively or negatively charged, when it loses or gains electrons according to its nature. Is it a metal? Is it a non-metal? So metals always get to donate electrons, then non-metals get to gain electrons. All right. So when metals uh, donate electrons, they become positive because the number of electrons reduces. Electrons are negative, so the number of negatively charged particles reduces, and so they become positive because the positive charges are dominating. Okay, and the opposite is true. So uh, here it is. The number of neutrons is also 8. All right. When it gets stable, when it becomes stable, the number of electrons, that's what increases. Oh yeah, it does increases. And when it increases, what happens? It means the protons will be less. By how many? By its valence. How many? 2. All right. So what we mean is, when oxygen is stable, electrons, protons, and neutrons come as follows. It gains 2 electrons. So in the outermost shell, there are actually 6. So for them to be 8, we need 2. So it gains 2 electrons. So altogether, they are going to be 10 electrons. All right. Then protons, 8. Neutrons, 8. Imagine. Let me just draw it and show you what we're trying to talk about. In the first shell of oxygen, we have 2 electrons. In the next shell, which is the second and last, which happens to be the valence electron shell, we have 1, 2, we have 3, 4, 5, 6. We said oxygen has 8 as the atomic number. So these electrons are already 8 altogether. So we are done here. But 2 more will have to be gained. And these 2 would have or can have been donated by maybe magnesium. Remember, I want us to relate this lesson to the previous lesson, the cations, because the true opposite is what we are just looking at. So magnesium, we said magnesium loses 2 electrons, right? So let's assume those 2 electrons are these. What is it? What is this oxygen becoming? This oxygen is becoming an ion because it's now stable. It has electrons 10 now. All right. Protons still 8. Neutrons still 8. So if we observe here, we're going to see that number of protons is now more than, the number of electrons is now more than the number of protons. Hence, the positively charged particles are less than the negatively charged particles. So which ones are dominating? We find that electrons are dominating, and the negatively charged particles, which happen to be electrons, are dominating. Hence, the whole atom becomes negatively charged. So what this means is we have to draw it like this. I have not emphasized on the first example, but get the emphasis from here. So after gaining 2, we're also going to do this and put to negative. For the first one, you just put a negative because it's monovalent. This 2 means divalent, so it's going to have 2 like that. All right. Hope we are together. Let's quickly go to the trivalent. All right. So, okay, you can pick nitrogen. In my head, I just have nitrogen right now. Nitrogen has the mass number of 14 and the atomic number of 7. All right. So we know that electrons, protons, and neutrons are going to have the following figures. So electrons are 7 because this number represents electrons. The protons are also 7. I'm sorry. The protons are also going to be 7 because it's a neutral the atom of nitrogen. So the protons and electrons are equal. What we mean is the positives and the negatives are equal, right? So 14 minus 7, 7. So even the neutrons is 7, all right? What happens to it when it becomes stable? When it becomes stable, it means these electrons that are 7 are going to be um, more by 3, since 3 is the valence, okay? Going to be more by 3, all right? So it's going to gain 3 electrons, all right? So let's draw it. Let's draw it and see. In the first shell, we have 1, 2. In the next shell, for them to be 7, we have 1, 2, 3, 4, 5, 6, 7. All right. So in the outermost shell, how many do we have? We have 1, 2, 3. We have 1, 2, 3, 4, and 5. Right. How many do we need for them to be stable? For each to have 8 in the outermost shell, we need 3. So aluminium, the cation in that previous lesson could have been the donator here of those 3 electrons. These lines are just showing us that they're coming from somewhere. They're coming from somewhere. This is not a mandate that I'm just doing this for fun, for comprehension, really. So how many electrons do we have now? 2, 4, 6, 8. Okay, so we are going to write it nicely here. 1, 2, 3, 4, 5, 6, 7, 8. Bearing in mind that the 3 are foreigners, they just donated. Okay, so to show that it's now an ion, we are going to do this and put a 3 there representing the number of electrons that have been gained. And excuse me there. So it's a negative because remember we said it's gaining, so you put a negative there. If you put a plus here with that 3, it means it's a metal, and that metal is gaining 3 electrons, but is donating 3 electrons. But hey, this is a non-metal and it's gaining 3 electrons, so this should be there. All right. So when it comes to writing equations, what was our first atom? That was mono. We used fluorine. So for fluorine, we're saying fluorine plus 1 electron. Fluorine plus 1 electron. What do we have? We have fluorine negative, like that. All right. The second one was oxygen. So oxygen plus 2 electrons. What do we have? We have oxygen as an ion, like that. All right. So the other one, the last one was I have to check it. Okay, so it was nitrogen. So what we're saying is nitrogen plus 3 electrons. What we just end up with is nitrogen 3 negative, like that. So when you add 3 electrons to this neutral substance, you have it stable. All right, you have it stable like that. So if you have a question, again, you can post, ask. Let's learn together. That's our motto. We are here to learn together. All right. So it's been Pearson, the science teacher. Once again, thank you for joining. Please learn, and when you learn, teach, because teaching is learning twice. That's what I believe. Teaching is learning twice. Thank you.